Today's lesson is the start of our new chapter on matrices. We are going to talk today specifically about matrix operations and going to kind of intro this and talk about some different things. So I always enjoy this. It's a lot of fun. We're going to talk about some different matrix vocabulary. We're going to talk about the dimensions. We're going to do some addition and subtraction. We're going to multiply, and then we are going to even solve for a variable with these, okay? There's a couple of new words on here. A matrix is simply an arrangement of numbers. The dimensions of a matrix are rows by columns, and we're going to talk about that a little bit more. A scalar is simply a constant with no variable. So when we multiply by a scalar, we multiply by 2 or 3 or 1/2, okay? So we're going to talk about all of these things as we work through. Like I said, a matrix is an arrangement of numbers in rows and columns, okay? So we're taking data and we're arranging it in rows and columns. Each number is an element of the matrix, and the dimensions are always given rows first, then columns. So this matrix shown here would be a 2 by 3, okay? It's got 2 rows, 3 columns. This is a 2 by 3 matrix. It's really important that you know how to state the dimensions, because that allows us to do other things with matrices. Once we know the dimensions, we can determine if we can multiply and do different things. So we really need to get this down. Okay, so letter A here would be a 2 by 2 because there are 2 rows and 2 columns. Okay, letter X would be a 1 by 2 because there's 1 row, or 1 by 4. I'm sorry, my bad. I see, it helps if you can count when you're doing this, because there are 4 different columns. Pause the video for a second and do the other 4, see what you can come up with, and then compare, okay? Letter E would be a 3 by 2. Letter H would be a 3 by 3. W would be a 3 by 1. And D would be a 2 by 3. All right, hope you got all those. Hope this is making sense for you. You just have to remember rows first, then columns, okay? When we are adding and subtracting matrices, we simply combine each of the elements in the same position. So what this sort of complicated picture is showing you is that to add 2 matrices, you add the top left plus the top left to get your value. And then you add the top right plus the top right to get your value. It's pretty easy. You just have to combine the pieces in the same position. Now, it only works to add and subtract if you have the same number of elements in the same dimensions, okay? You can't add like a 2 by 3 plus a 3 by 3. That won't work because there's too many elements in the 3 by 3. They don't all have a match in the 2 by 3, okay? So the first thing you want to check when you're adding or subtracting is, can I do this? Do they have the same dimensions? So let's just check. This one here is a 2 by 2. This one is also a 2 by 2, which means that we are okay to add. So what we're going to do is we're just going to add the positions. 3 plus -1 is 2. 0 plus 4 is 4. Notice how I'm adding the top left and I'm going to put it in the top left. I'm adding the top right and I'm putting it in the top right. I'm going to add the bottom left and I'm going to put it in the bottom left position. And I'm going to add the bottom right and I'm going to put it in the bottom right position. So there is my new matrix. That is the sum of these 2 that are shown. Okay? Go ahead and pause the video again. Try this next one. See what you can come up with. Don't forget to compare the dimensions first. So hopefully you noticed that the dimensions were a 3 by 2 and a 3 by 2, which means that we are okay to subtract. So then when you do that, you get 9, -1, -3, 8, 2, and 5. Be very careful with subtraction because remember, like this is 7 minus -2, which makes it 7 plus 2, which is 9, okay? So be very careful. Also feel free to check my math. Just make sure that I did that right. I feel pretty confident about it, but if you notice a mistake, please let me know. Go ahead and pause the video and do these 2 real quick and see what you come up with, okay? I hope you noticed that this one on letter C does not have the same dimensions, so it cannot be combined. I hope that you're kind of paying attention to the dimensions so that you can see that they can be combined. Now, letter D does. Both of these are 2 by 3s, so then you just have to combine the different pieces. And you get, let's see, 1, 0, and 6. Here you go. And then don't forget to draw the bars to show that it's a matrix. Okay, we always kind of frame those in with those brackets to show that this is a matrix, which is an array of numbers again. Okay. Order of operations does apply to matrices. So you always multiply before you add or subtract. And then just a little note here, scalar multiplication is when you multiply a matrix by a number. So we can take an entire matrix and we can double it or triple it or half it or quarter it or whatever. And to do that, we take each element inside and multiply it by whatever that scalar is. So we're going to practice this a little bit. It's pretty simple if you think about it. So what I'm going to do is I'm going to take this matrix here and I'm going to multiply it by -2, which means that I'm going to multiply each of the elements inside by -2. And I get a new matrix that is times -2 of the first one. Okay, this next one, I'm going to multiply every element by -4. So I'm just going to go through and multiply every single one by -4. Pay attention as you're doing this. You don't want to miss one. Also, remember how to multiply. We got to kind of go back to basics here and remember how to multiply correctly when we're doing this. Okay, and we get this. All right, not too terribly bad. We got some basic operations here with matrices. Now, this one is where our order of operations comes into play. Okay, and notice it says, if possible. That means that you want to be checking the dimensions. I didn't do that on the last two, but you really probably should. Just check the dimensions and make sure that you can actually combine them because they are the same. Now, these are both 2 by 2s, so I'm going to be good. So my order of operations tells me to multiply the first one by 4 and then to add them together. So I'm going to go through and I'm going to multiply this first one by 4 really quick. There we go. And then I'm going to add it to this second one. And then I'm going to get a solution. So when I add -8 and -3, and then -32 plus 8, and 20 plus 6, and 0 plus -5, and there is my final matrix. So remember your order of operations, okay? Parentheses, then exponents, then multiplying or dividing, and adding or subtracting, all right? All math operations that you can do with numbers, you can do with matrices. This allows us to even sometimes solve for missing parts. So for example, notice in this first one, I have an X and I have a Y. What I know is that 5 times this matrix here on the left is going to be equal to what I got in this answer over here. So I can say 5 times X is going to be equal to its corresponding part, 15. Well, that's a pretty easy one to solve then because X is just 3, right? So if I put a 3 in here and then I were to multiply this scalar by the matrix, I would get 5 times 3, which gives me 15. Notice 5 times 9 is 45. 5 times -3 is -15. So then 5 times 2y is going to be equal to 40. Well, 10y is equal to 40. That means that y is equal to 4. So now we can solve for some missing parts. I always kind of enjoy this. This is kind of fun. It's sort of a little matching puzzle, and you just got to match up the pieces to find what the variable is equal to. So pause the video real quick. Try this next one. See if you can solve for x and y, and then compare your answers. So hopefully you set up some equations, which then, of course, are pretty solvable. We can do that one pretty quick and get that y equals -2. And then, of course, we know that x plus 9 is equal to 13, so x is equal to 4, okay? I hope this is kind of making sense here. Are you kind of seeing what's going on and how we're solving for the variables by using our matrix operations? Because we're going to do this one, and it's kind of fun. So we're going to kind of put the pieces together. Let's think about what's happening on this left side as we look at the right side, okay? So we have some parentheses, meaning that we would do what's in the parentheses first. So we would take -3x plus 9. And that's going to give us our top left of this matrix inside but then we're also going to multiply it by -2, and then that's going to bring us over to be equal to 12. Notice we just set up a nice little equation, and we can solve this out. So we can multiply, distribute the -2, and we get 6x minus 18 equals 12. We can add 18 to the other side, and then we can divide by 6, and we get x equals 5. So a little more complicated, but if you just remember your order of operations, right? Parentheses, exponents, which we really don't do with matrices, multiply and divide, or add and subtract, and then you just follow the order there, and we can set up a nice little equation. So again, try pausing the video, try it for the 2y, and see what you can come up with, okay? So hopefully you took 2y plus 3, you multiplied that by -2 and set it equal to -18, and then you could just solve. Now I'm going to solve this one a little differently. I'm going to divide by -2, which is also a valid solving process, not solution, that allows me to solve. So on the first one I distributed, that's valid. On the second one I divided, that's valid. You can do either one, okay? Hopefully this is kind of making sense for you. Hopefully you feel like you're good with adding and subtracting matrices. You understand what a scalar is, and you can multiply by 1. You can solve for a variable, which means that you are great on solving and performing matrix operations.